Hello world! My name is Code Eric, and I've been working on this app called Zerv, but I'm hoping this channel is helpful for you in other ways, and maybe even entertaining. I want it to tickle your brain a little bit. So today I want to talk about what it's like from the client side when you make a request to the server and it fails. What do you do when that request to the server fails? And of course, there are basic things like showing the error to the user and allowing them to retry, but I'm going to ask you a question. What are the different protocols you need from the client side when a request fails to the server? How many different protocols do you need? I can think of about 3 different protocols, 3 different things that you need to be able to do to deal with a failure that's happening on the server, or a network failure, some sort of error that's happening between you and the server. Now let's dive into it. The first use case is when you're getting something from the server and that request fails. The second case, I bet you'll see this one coming, is when a mutation fails. You're trying to change something on the server and that falls through. Now the last case is actually a bit of an edge case. It's a bit of a mystery, and I'm sorry, you're gonna have to stay till the end of the video to hear what is this unique case where sometimes you want to be able to retry, but you can't actually retry. And we'll talk about the third case in a minute, but first let's cover the simpler cases. What happens when you're trying to get some data from the server and that fails? On a typical request, it looks like this when it succeeds, right? You request the data from the server and it comes back. And when it fails, it looks like this. And in the case of a get, you can kind of continue trying without much, without many bad things happening, right? So in fact, you don't even have to wait for the user to press a retry button. In fact, you can go ahead and start retrying automatically, just in case, maybe the server comes back online, or maybe the error that's happening server side gets fixed. You want your client to be automatically retrying. And that's a very simple use case. In fact, even if your client gets disconnected from the server after a successful request and it gets reconnected, you might want to get again as soon as you get reconnected, because maybe the data has changed and you want to show the user the up-to-date data. As long as you're getting the data that the user is currently looking at, that's not really wasteful. So that's pretty simple handling for what happens when you are trying to get some data. And when you're mutating some data, it can be more tricky, but it's not always more tricky. Maybe you're trying to set some value to the server, you take some value and you send it to the server, and maybe it's fine if you just do that twice. Maybe you're just setting some value and you can set that value the second time, and that second request is doing the same thing as the first request does. And that's a feature called idempotency. What that means is that when you do the same thing twice, it actually doesn't do anything the second time. It means that you can safely do something several times without it necessarily having several effects. It's only going to have effect. So if your mutation here is idempotent, then you're all good. But there are cases where your data is not necessarily idempotent. Like if your mutation is trying to add some value on the server, like add an item to the list, or maybe increment some number, well, that's not necessarily something that you can just retry, because then the server will have maybe added it twice. Just because there's a failure here on the client after one of the requests doesn't mean that the other requests or it doesn't mean that the request has actually failed. It's possible that the server has accepted this new value and that the error has happened somewhere in between the server's response and you getting that response. So we need to handle this case better, because this is a problem. We've gone and created a double mutation. Now there's 2 values on the server when we only meant to create 1. So the trick here is to make this request idempotent. And the way we do that is we add a special token to our mutation, a special little identifier. And this ID is going to be sent on the retry as well. So that's what this little orange blurb is. We're basically retrying with the same token. And the reason this actually works, the reason this is successfully idempotent, is because the server remembers that token. And the server sees, oh, you actually have already done this before, so we don't need to go ahead and add again. So that allows the client to have a retry behavior that's really polished, but from the server perspective, it's not going to be screwing up and doing your behavior twice just because you've retried it. So those are mutations. And boom, already we've talked about most of the times where you're going to need to retry queries for the server. You'll need to retry them when you're getting and when you're mutating. But what's the third case? Well, the third case, to put it in a very generic and useless abstract sense, It's what happens if you need to delete something on the server and the client at the same time, like immediately, like all at once. Now, this sounds like a crazy convoluted use case, but actually this is really common. Almost every app should be doing this when you log out. So that's what needs to happen. For security purposes, it's really important that you log out on the server and the client at the same time. But you still need to be able to retry that request, right? So let's get into it. So when you're making a request that is an authenticated request, you have a session. You have this key. You're sending to the server, and then the server is using that to identify you in order to send you back the protected resource that you're getting in this case. Now, but we need to talk about like what it actually even means to log out. I think this is really important to understand properly because from the server perspective, logging out is different from the client perspective. Now, on the server's perspective, the server needs to take this token and throw it away and stop respecting this token immediately, because what the server is doing when a logout is happening, it needs to recognize that this session that was being used can no longer be used. Now, for any subsequent requests after the logout, even if the client has the correct token, we're no longer going to respect this session anymore. So this is what it's like from the server. Server side, we need to throw away the token so that we're stopped respecting it. On the client side, we actually need to do the same thing. We need to immediately throw away that token. Immediately throw it away, regardless of whether or not our request to the server actually works out. Because if the client falls into the wrong hands, we want to make sure they don't have access to this token. So this is all part of a secure logout process. You need both things to happen. Now, here's perhaps what a solution could look like. We need to handle both of these things at the same time. We need to delete the token from the client and also from the server and be able to retry the request to the server. So let's say that our session is two different pieces now. It is an identifier, which is this puzzle piece, and it's the secret itself, the token. And now that we've split our session into two different pieces, we can have some special behavior around it. Where on the client, we are immediately going to log out by throwing our secret away, client side. So that way anyone who has access to the client, anyone who has access to the app or the web browser will no longer be able to access the token. And using the session identifier here, we can send a request to the server asking the server to delete the whole session. And what's important about this is that this process is retriable. So you've securely logged out from the client side, but now the server has the ability to, or you have the ability to repeatedly ask the server to destroy the session and stop respecting sessions of this identifier. So this is a really important security behavior to have. And in this case, we can log out. If it fails, this is what the retry case looks like. We're able to successfully go back to the server again and again, even though we're already logged out from the client. Cool. I think this is really exciting. It's a fun edge case, what it's like when you actually log out. I know you're wondering, like, hey, this is a Code Eric video. I'm going to be disappointed if I don't see the code. I'm sure that's what everyone's thinking, right? Like, everyone here loves the code. So I'm going to show you what the code looks like inside of the Zurv React Native app when we log out right now. And it's relatively straightforward. Even though it's not perfect from the user perspective, it's going to be pretty good. So we only have a single logout function on the client side. And immediately what we do is we clear the session token. And this basically means that the client is no longer logged in from the client's perspective because the token is gone. Then we do this request to the server that might fail. And if the request to the server succeeds, then we're going to forget about the session altogether. If the server request fails, though, what happens is this whole logout function will fail. The user will see an error, and the user is going to be in some weird half logged in state for a while. And at that point, they can go ahead and make sure they're reconnected to the server and press logout again. And then it's going to be able to go to the server. If it hits the server correctly, it will log them out entirely. So it kind of forces the user to do the retry behavior for logging out. This is a really secure way to make sure that we've logged out client side and server side properly at the same time. So yeah, this has been a real fun video to make, actually, just talking about all the different strategies that you might have to take when your request fails, either on your website or your mobile app. And of course, we're working on this on Zurv. A lot of these strategies aren't perfectly implemented in Zurv. In fact, even the logout strategy, I'm sure, might have some issues. But thanks so much for taking a look and following along, and I'll see you in the next video.